Welcome back. Last time we were here, we were talking about solving systems of equations, and we looked at solving them using substitution. A system of equations has two equations in two variables, or three equations in three variables, or any number of equations. The catch is the number of equations you have and the number of variables you have to be the same. Now, when we looked at solving with substitution, our objective was to take one of these equations, get one variable by itself, and then take what that variable was equal to and sub it in place of that variable in the other equation. Then once we did that, we had an equation that was all in one variable. We could solve that equation, take that solution, back up to one of the previous ones, and solve that equation for the second variable and have answers for both variables. Now the trouble with that, if you remember, we had two equations up here and we filled up this whole column of the board. Substitution takes a little bit of time. It's not overly difficult, but it is kind of tedious. So what we're going to look at this time is elimination. Now elimination works with in the same world. Okay, it works with systems of equations, two variables, two equations. But instead of subbing something in place of one of the variables to get an equation that's all one variable, we're going to get rid of that variable. So the first thing that needs to happen is we need to have a common coefficient. So that means the number multiplying the variable has to be the same in both equations. So for instance, if we look at this example, we see that both of the x's have a 2 in front of them. That's the common coefficient. That's what we want to have. Sometimes we have that right from the jump. Sometimes we have to do a little bit of work to make it happen. Okay, but that's got to be the first step. Once we have that common coefficient, what we're going to do is either add or subtract the entire equations, and that's going to cancel that variable. So that variable that has the same coefficient both times, we're going to get rid of it. We're going to get a new equation without it, all in one variable that we can solve. And once we have that solution, we'll have x equals 3 or y equals negative 2. We'll sub that back to one of the original equations, and it doesn't matter which one, and we'll be able to solve that equation as well. And then we'll have both x and y. Okay? Now let's take a look at this in action. So I have 2x plus 6y equals 14, and 2x minus 12y equals 32. Now like I said, these x's both have 2's in front of them. So what I want to do is totally cancel those x's. So I need to choose whether adding or subtracting is going to eliminate these. Well, if I do 2x plus 2x, that gives me 4x, doesn't cancel. But if I do 2x minus 2x, that will cancel, it gives me 0. So what I like to do is I draw the kind of the equals line underneath both equations, and whatever operator I'm going to use, I circle it. So I have 2x minus 2x cancels completely. And then I have 6y minus a negative. Now minus a negative, remember, means plus plus. So I've got 6y plus 12y is 18y equals, okay, 14 minus 32. If I subtract those, I'm going to have 18. So 18y equals 18. Now, this worked a whole lot faster than substitution to get that variable, or excuse me, to get an equation all in one variable. Now we have it, the rest of the process is the same. We solve that new equation, and then we'll sub that solution back into one of the originals to solve for the other variable. Anyway, divide both sides by 18, and we have y equals 1. Excuse me. 14 minus 32 is going to be negative 18. Negative 18 divided by 18 is negative 1. Watch out for those. Always check your work. Make sure your answer makes sense. Now, I have what y is equal to. I want to take what y is equal to and sub it into one of the original equations. Now, guys, it does not matter which one of these we sub it into. I'm going to sub it into this guy, the first one. It has smaller numbers, easier to work with. That's the reason I'm going to pick this one. So I've got 2x plus 6 times, instead of y, negative 1 equals 14. Well, 6 times negative 1 is negative 6. Add 6 to both sides. Okay, and I've got 2x equals 20. Divide both sides by 2. And I've got x equals 10. So our solution is the ordered pair 10, negative 1. And there we go. Okay, now, next one. Starts out very similarly, two equations, two variables. The catch is this time, neither one of those variables has the same number in front of it both times. So I need to get that number the same in front of one of those variables, and it doesn't matter which one. Last time I got rid of the x's, so this time I'm going to get rid of the y's. So I've got 5 and 4, and I need to make both of them the same number. So what I have to do is multiply them by something. So the common factor, or the common multiple of 5 and 4 is 20. So in order to get 20, I have to multiply this whole equation by 4, and this whole equation. In order to turn this 4 into 20, I need to multiply the whole equation by 5. So for the top one, distribute that 4, and we'll have 12x minus 20y equals 24. Distribute the 5 in the second equation, and we'll have 10x minus 20y equals 20. Now, I want to cancel these y's, and I have negative 20y and negative 20y. If I add those together, I'm going to have negative 40y. So what I need to do is subtract them. So I'll subtract the entire equations. So 12x minus 10x gives me 2x. Negative 20y minus a negative. Minus a negative means plus plus. So negative 20y plus 20y cancels. And then 24 minus 20 gives me 4. Okay, so now I've got an equation that's all x's. Pretty easy one to solve. Divide both sides by 2, and we have x equals 2. Now, once we have what x is equal to, we can take it and sub it into either one of the original equations and use it to solve for y. Now, it doesn't matter which one we sub it into. I'll sub it into this guy. So we'll have 2 times 2 instead of x minus 4 times y equals 4. Well, 2 times 2 is 4, minus 4y equals 4. Subtract this 4 from each side, and we'll have negative 4y equals 0. Divide both sides by negative 4, and we get y equals 0. Now, we might see y equals 0 and think, oh no, that's an error. But guys, 0 is a number, okay? How many Ferraris do you have in your garage? 0. It's fine, okay? So 0 is a perfectly acceptable answer. So our answer here is the ordered pair 2, 0. Okay? Now, last one. Okay, same thing to start with. I've got 3x minus 5y equals 17, and I've got let me try this again. 4x minus 5y equals 17, and 3x plus 4y equals 5. Now, I need to get a common coefficient in front of one of those variables. And there's really no wrong answer. Let's see. Tell you what, I'm going to solve for, I'm going to eliminate y again. So I see the 5 and I see the 4, and just like last time, I need to make those both a common number. So the common multiple between 5 and 4 is 20. So I'll multiply this equation, the top one, by 4. And I'll multiply the second equation, in order to turn 4 into 20, by 5. So if I distribute this 4 up top, I'll have 16x minus 20y equals, let's see, that'll be 68. 5 times 3x is 15x. 5 times 4y is 20y. And 5 times 5 is 25. Okay, now, I want to get rid of those y's. So I have negative 20y and positive 20y. If I do negative 20y plus 20y, that's going to cancel. So this time, instead of subtracting the equations like I did on the last two, we're going to add the two equations. So 16x plus 15x gives me 31x. Negative 20y plus 20y cancels. And 68 plus 25 is going to be 93. Okay, now I want to get that x all the way by itself. So I'll divide both sides by 31, and I'll have x equals 3. Now, once I have what x is equal to, I can take it back to one of these original ones, and it doesn't matter which one, and solve for y. So I'll take x equals 3, and I'll put it into this second one. So 3 times, instead of x, 3, plus 4 times y equals 5. 3 times 3 is 9, plus 4y equals 5. Subtract 9 from both sides. 4y equals -4. Divide both sides by 4, and I get y equals -1. So our solution for this system of equations is the ordered pair 3, -1. So, elimination can work a little bit more quickly than substitution, but it does require a little more thought along the way. First, we need to get that common coefficient. Then we need to choose whether to add or subtract the entire equations. The process, however, works a little bit faster. Okay? Get that common coefficient, either add or subtract the entire equations to eliminate one of those variables, solve that new equation that's all in one variable, and then sub that back into the original equation, either one, doesn't matter which one, and solve for that remaining variable. Remember that your solution is going to be an ordered pair for a system of equations. Okay?